Hello everybody, in this video we are going to see eigenvalues and eigenvectors. So for that first see this, if Ax is equal to lambda x, what is this means? This is our n square matrix that is of order n into n, and this is a column vector. Column vector means it will have only one column and it could have as many rows as possible, and this lambda is our eigenvalue. This is a scalar value means it is only a quantity form. It doesn't have any direction. And this x means this x will be this our x column vector will be called as eigenvector when it will satisfy this equation. When this equation is satisfying, that is ax is equal to lambda x. So now we have this equation. So now from this equation we can have ax minus lambda x is equal to 0. Now we can take x common. So we are left with a minus lambda I into x is equal to 0. Then by having this determinant value 0, you can have this determinant value 0, and solving this determinant you could get lambda values, possible lambda values, and that will be our eigenvalues. And that will be our eigenvalues. Now you got a lambda value, then putting that into this equation a minus lambda I into x is equal to 0. Putting lambda values into this equation, you could get x. X means x is our eigenvector. So in this way, you could get eigenvalues and eigenvector by solving this equation ax is equal to lambda x. Using this given equation, you could find eigenvectors and eigenvalues. So there are possible, for example, if there are two eigenvalues, so there will be two eigenvectors corresponding to those two eigenvalues. Basically, what are eigenvalues and eigenvector? Basically, if you have this A matrix, for example, that is 1, 2, or 2, 4, and another column vector you have 1, 2. So if you multiply by A into x, then you will get 5 by 10. So if you see this on the graph, for example, if you have this column vector 1 comma 1 and 2, so it will be like this. In the x it will be 1, and in the y it will be like 2. Means for example it will be 2 and here it will be 1. So this is your column vector. So by multiplying it with a, you could have 5 by 10. 5 10 means in the x it will be 5 and in the y it will be 10. So you can extend this. So you can see that the ax is not rotating, it is on the same as it is on the same path as this x, but it only scales. It is scaling by, you can see it scales with some value. With this value it scales. So this value is called as the value with each it scales, with which it scales, it is called as eigenvalue. And the column vector that scales is called as eigenvector. So this column vector is scaling, so we can call it as eigenvector. But in another case, if we take, you have this A matrix has 1, 2, and 2, 4, and another column vector you have 1, 1. So if you consider this, so this you have this 1, 1, so it will be here like 1, 1. But if you multiply this A into x, then you will have 3 by 6, 3 6. So 3 6 will rotate like this. This rotates with respect to this column vector. It scales but rotates also. So we can't say that this column vector is a eigenvector. Why? Because this ax, when we do ax, so this vector rotates. It scales with some value, that will be our eigenvalue, but it is not a eigenvector. Why? Because it rotates with respect to this column vector. So this column vector could not be a eigenvector. So basically the eigenvalues and eigenvector concept that I know that it is applied in the mechanics. For example, if you have any, for example, you are applying some external force or something, and if you are seeing some vectors that are scaling or that are rotating or not, then you could have their real life application. It's all about scaling and rotation of vectors with respect to given conditions or a given treatment.